theorem. Chinese remainder theorem. So this is very important. So statement let m1 comma m2 comma m3 so on m suffix r be pairwise relatively prime numbers such that here relatively prime means any two, if you take any two number either registrally ಯಾವ್ದಾದ್ರು ಎರಡು ನಂಬರ್ ತಗೊಳ್ಳಿ that GCD I will take here mi comma mk is 1 here mi ಕೂಡ ಇದರೊಳಗೆ ಇರ್ತದೆ mk is also within this inside only ಈ ಎಲಿಮೆಂಟ್ ಒಳಗೆ ಇರುತ್ತೆ so I am taking two product here ಎರಡು ನಂಬರ್ ತಗೊಂಡ್ರೆ GCD should be always 1 so one condition is there for I is not equal to k. I is not equal to k. Then the system of linear congruences or here x is congruent to a1 into mod m1 x is congruent to a2 mod m2 here x is congruent to a3 mod m3 so on x is congruent to a suffix of mod m suffix r mr here a1 a2 a3 or a up to a suffix r be arbitrary integers. So remember that one. Okay, no need to write the this one, no need to write here in statement. Now proof. So let I'll define n equals m1 comma m2 comma m3 so on up to m suffix r. Next line here for k equals I am taking for k equals 1 comma 2 comma 3 up to r comma here I take n suffix k. Here nk equals n divide mk. N divide mk. So if n divided, what is n? N is the up to here, that means it is m1 n equals m1 m2 m3 m4 so on. You will get mk minus 1 mk plus 1 mk plus 2 so on up to mr you will get. So this is your n. So if you divide mk here, so mk get cancelled here, so what is the remainder here? N suffix nk you have to get here m1 comma m2 comma m3 so on mk minus 1 mk plus 1 so on mr you will get. By hypothesis means above statement, by above statement the mi are relatively primes in pairwise or pairwise or pair, so that such that so what you can GCD here, what you get GCD of here product of two numbers, this is nk comma mk, you are dividing with mk, right? So these two of GCD is 1. Product of any two prime numbers you will get here, you will get GCD is always 1, so that is relatively prime numbers. Remember, product of two prime numbers is always GCD is 1. So here also find out for nk means here we are taking mk. If you take k is equal to 1, you will get n1, here m1. If you take 2, you will get n2, you will get m2. So here only these two will get changes. So product of these two numbers, GCD of these two numbers is always 1. So next line. Okay. So thus nk equal nkx is congruent to 1 mod mk. 1 mod mk. We are writing from the definition for congruences. Here by using this one we are writing the definition of congruences. So here you will get this one. So as a unique solution xk, unique solution xk. So here our aim is to prove that x1 equals a1 into n1 into x1. We are expanding this one, so plus a2 into x2 plus a3 n3 x3 plus so on, plus here ar nr xr you will get is a simultaneous solution of the given system of linear congruences. So first we observe that here ni is congruent to 0 mod mk for I is not equal to k. For I is not equal to k. So we are writing for this one linear congruences using definition of congruences. Here using this one we are writing the definition of congruences. So we will get this one. Now since since mk divides ni. So by linear congruence here, what do you get? A divides, A is congruent to 0 mod b, means here A divides b minus, b divides a. You can write b divides a. So here also mk divides ni. Thus the result is x bar equals, here x bar equals, this can be written as here a1 into n1 into x1 plus a2 into n2 into x2 plus so on, plus ar into nr into xr. So x bar is congruent to, this can be written as ak nk x to the power xk is mod mk, because here a1 n1 x1 plus a2 n2 x2 plus so on, plus you get ak nk xk plus so on, plus you get ar nr x to the power of r. So here all are you will get 10 0, but here you will get remainder will be remainder is ak nk x to the power of k for the above this one. So using this one, so you will get this result. So also xk was chosen such that it satisfies here nk x is congruent to 1 mod mk. So here you have one theorem for congruences. Using this result, I am using that result here. So what I get here xk, here nk, this can be written as xk is congruent to 1 mod mk, 1 mod mk. So that means here, because xk satisfies the congruences. So xk is also satisfies the congruences. So you get this result also. So this can be written as here x bar is congruent to ak into 1 mod mk. So I am substituting here. What is nk? Nk is nk into xk is 1. So nk into xk is 1. So I am substituting here. So we get this result. X bar is congruent to ak 1 mod mk. So therefore, what do you get? X bar is congruent to ak mod mk. For all k equals 1 2 3 so on up to r. So therefore there exists a solution. Therefore there exists a solution to the given system of linear congruences. Linear congruence. So this satisfied, right? So there exists a solution to the given of system of linear congruences. Now you have to prove it is an uniqueness. So for uniqueness, so you have to prove it is an unique solution. Suppose x dash is any other solution. I am taking x dash is any other solution of these congruences. Then we can write x bar is congruent to ak mod mk. So I am taking this one. So instead of ak I am taking another one. Here x bar not instead x bar. Instead of x bar I am taking x dash is congruent to ak mod mk. So this implies that x bar is congruent to x dash mod mk, or you can write x dash is congruent to x bar mod mk. Both are same, no problem in that one. So for all k equals 1 2 3 so on up to r. So here by using congruence definition, here also we can write mk divides x bar minus x dash for each k, since GCD product of two prime numbers. So we get mi comma mj equals 1. So what I get here, and that one mk. So what I get here, since m1 m2 m3 so on up to mr divides, here this can be written as this one divides x bar minus x dash. So this implies that, so this can be written as n. So this can be written as n. So n divides, what do you get, x bar minus x dash. So this can be written as by using the congruence definition. So this can be written as x bar is congruent to x dash mod n. So we will get an unique solution. You will not get so many solutions, only you will get unique solution congruences. So this proves use the uniqueness. So turn the program, solve the given system of linear congruences. So x is congruent to 1 mod 4, and here x is congruent to 0 mod 3, x is congruent to 5 mod 7. So here a1 equals, here a value is this one and this your m value. So a1 value is 1, a2 value is 0, and here a3 value is 5. So this one. So here by using a1, a2, a3, this one m1, m2, m3. So those values I'm writing here. So what do you get? M1 value is 4, M2 value is 3, and M3 value is 7. Next, what you here we want here we want nk here. You have to find out small n value. So small n value, how to find out small n value? Small n value means m1, m2, m3, m4, so on up to mr. So you have to take the product. So that means n equals m1 into m2 into m3. Only up to m3 is there. So n equals 4 into 3 into 7. So you will get, if you multiply, you get 84. Now next we have to find out nk. So what is the formula? Nk equals small n divided by mk. So nk, we have nk equals n divided by mk. So here put n equals 1. So n1 equals n divided by m1. So what is n? N is 84 divided by what is m1? M1 is 4. So how much will get? It will get 21. Next here put n equals to, sorry, k equals to, what do you get? N divided by m2. So n is 84 divided by m2 value is 3. So if you divide, you get 28. Put k equals 3. So n divided by, what do you get? m3. So 84 divided by, what is m3? It is 7. So if you divide, 7 12s are 84. Now we know that nk into x congruent to 1 mod mk, right? So here I am using this one. Here nk into x congruent to 1 mod mk. So here if you put nk equals 1, you will get n1 into x. What is n1? It is 21. X is congruent to 1 mod. What is m1? m1 is 4. Next here what do you get? 28. X is congruent to here 1 mod 3. Next here 12x is congruent to 1 mod, here 1 mod, what you get? m3 is, what you get? It is 7. So now we have to choose the x values. X1 value, x2, I am calling this one x1, x2, x3. So we have to choose the x values here. So how to choose the x values means, if you multiply with this integer, if you divide with 4, remainder will get 1. So how much if you multiply here x? So I am putting x is equal to 1, I will put x here. What do you get? 21 into 1 equals congruent to 1 mod 4. So 21. So if you divide with 4, 5 4 here, 20 is there. What do you get? 4. 21 is there, right? It is 21. So if you divide with 4, 5 4s are 20. So what you get? Remainder is 1. So that means, therefore, here I'll call it as x1 equals 1. And here, what you get? How much here value? How much integer? Yesterday in the multiplier will get remainder is 1. So 28 into 1 is congruent to 1 mod 3. So here 3 28 3 3 nines are 27. What is the remainder? Remainder is 1. So therefore x2 equals 1. Now here what do you get last? 12 into here what is congruent to 1 mod 7. So what do you get? 7. And here if you how much if you multiply you will get here remainder is 1. So 12 I'll multiply with 3. So 12 3s are 3 to 6 and 3 36. So how much you get? 7 5s are 7 5s are 35. So what you get? Remainder will get 1. So therefore x3 equals, you are multiplying with 5. You are multiplying with 3. You are multiplying with 3. Now therefore what you get? X bar formula, x bar equals a1. Here what is x bar formula? So x bar is what you get? a1 into n1 into x1 plus a2 into n2 into x2 plus a3 into n3 into x3. So x bar equals what is a1? a1 is 1 and n1 here, how much n1? n1 is 21 into what is x1? x1 value is 1 plus a2 value is 0, n2 value is 28 and x2 value is 1. X2 value is 1 plus a3 value is 5 and n2 value, what do you get? n3 value is 12 and what is x3 value is 3. So if you here this now whole term becomes 0, this one, so 5 3 is 15, 15 into 12 25, 25. So we'll get it is 201 x bar. So this implies that x is congruent to 201 mod here what do you get? N here, n value is 84. So 84. So what do you get now here? So if you divide with 84, so what do you get? 201. So what do you get? 2 is 168. Remainder is 33. So x is congruent to 33 mod 84. So now use congruence definition. Here congruence definition. So what do you get here? X minus if you use congruence definition, what do you get? 84 divides here what do you get? X minus 33. So this implies that here use divisible property. So what do you get? X minus 33 equals 84 n, some integer n I will take. So x equals 84n plus 33. So this is the required solution. So how to check this? For n equals 1 2 3 4 so on. So how to